reflect democratic values. And today I'm going to help set some of the broader context for what are U.S. AI priorities before we dive into the infrastructure questions that will drive this panel. So as the global leader in AI development and industry, the U.S. is committed to sharing its technologies to enable countries around the world to realize the economic and societal benefits of AI. Last July, President Trump released America's AI Action Plan that reflects a fundamental truth. AI is a foundational technology that will define economic growth, national security, and global competitiveness for generations in the future. The action plan is built on 3 pillars. First, strengthening American AI innovation. We're promoting U.S. AI leadership to ensure Americans benefit from AI's transformative potential while avoiding overly precautionary regulation. AI systems must be built from the ground up with freedom of expression in mind. Second, we're building American AI infrastructure. President Trump signed an executive order to accelerate federal permitting of data center infrastructure, recognizing that AI leadership requires the physical foundation to support it. This is directly relevant to today's discussion around energy systems and data centers. Third, leading in international AI diplomacy and security. We launched the American AI Exports Program to promote full-stack American technology packages, and we want to make it easy for friends and partners around the world to adopt U.S. AI technologies that have been proven through performance, trust, and security. So AI infrastructure isn't just about compute, it's also about the entire ecosystem that makes AI possible, including secure, reliable energy systems. So as AI scales globally, data centers are becoming critical infrastructure and catalysts for energy system modernization. The AI race will determine not just our technological leadership, but also the balance of power and wealth of nations. It will determine whether democratic values or open markets it will determine whether democratic values in open markets or authoritarian models guide AI's development worldwide. And the U.S. wants to partner with countries around the world to build long-term capabilities and become AI creators, not just consumers, contributing to a vibrant global ecosystem. I think the technical challenges that you'll discuss today on this panel on high-efficiency data centers, intelligent power systems, energy optimization, they're not just engineering problems. They're really strategic imperatives that shape which countries can fully participate in the AI revolution. So I look forward to the panel, and I'll turn it over to the moderator. Thank you.
Good morning. My name is Jacqueline Cochran, and I am Associate Lab Director of the National Lab of the Rockies, formerly known as NREL. And I'm really excited to bring up my panelists. Could you all please come up? Good morning. My name is Jacqueline Cochran, and I am Associate Lab Director of the National Lab of the Rockies, formerly known as NREL. And I'm really excited to bring up my panelists. Could you all please come up? Will strain power systems, but whether leadership, technology, and policy can ensure that they strengthen power systems and economic resilience. So before we dive into questions, let me quickly introduce our panelists for today. My name is Jacqueline Cochran, and I am Associate Lab Director of the National Lab of the Rockies, formerly known as NREL. And I'm really excited to bring up my panelists. Could you all please come up? Will strain power systems, but whether leadership, technology, and policy can ensure that they strengthen power systems and economic resilience. Next to him. So before we dive into questions, Chairman and Managing Director of Grid. My name is Jacqueline Cochran, and I'm Associate Lab Director of the National Lab of the Rockies, formerly known as NREL. I'm really excited to bring up my panelists. Grid stability and will strain power from the technology side. Whether leadership, technology, and policy can ensure that they strengthen power systems and economic resilience. Next to him. So before we dive into questions, Chairman and Managing Director of Grid. My name is Jacqueline Cochran, and I'm Associate Lab Director of the National Lab of the Rockies, formerly known as NREL. Energy projects at Amazon Web Services, where he focuses on integrating AI data centers with local systems and long-term primary elements from the technology side, whether leadership, we have knowledge on policy experience, strengthen power systems, and economic development of next generation AI My name is Jacqueline Cox, and I'm Associate Lab Director of the National Lab of the Rockies, formerly known as Energy Projects at Amazon Web Stability, where he focuses on integrated deployment in large-scale AI data centers, with local systems, looking at how AI data centers are already technology side, whether leadership, we have knowledge on policy experience, strengthen power systems, and economic development of next generation. My name is Jacqueline Cox. Okay, we're going to start with you, Mr. BRPL manages energy projects and stability, where he focuses on integrated deployment in large-scale AI data forecasting, looking at how AI technology side, whether leadership, we have knowledge on economic development of next generation. Okay. Okay, we're going to start with you, Mr. BRPL manages energy projects and
certain hyperscalers which is maybe hardly 20-25 kilometers away from South Korea. They come down. Now if we do not plan them according to
development of next
planning, when we do forecasting of the demand and the planning, it's not only from the content perspective. It's not about power scalers, which is maybe hardly power can be used from South Korea. Now if we do not plan them according to it's more about the network. Suppose you have the heart of the demand section, that 1 gigawatt will not be able to do forecasting of the demand and the planning as early as 20 kVA, not only from the content perspective, it's about power scalers, which is maybe hardly. Therefore, it is not going to impact the medium and low scale. Now, if you do not plan, but just the way in India to be outside central level, state level, it's more about that level of the planning. Suppose where the heart and the where the grid substation devices is provide 1 gigawatt will not be able to forecasting of the demand and the state. Apart from this, not only from the countries, the base load is very scalers, which is therefore it is stable. The medium and low the initial sources. So but they would have to be also to be outside stable. US we are just starting maybe stages another 10 years. It's more about that level to understand. So for the time being, there has to be a mix of a cloud and where are you going to grid substation or by using income or by 1 gigawatt. So apart from grid, you should have a local say apart from 6 hours, 8 hours, and this the base load is very scale of technology more opinion. Therefore, it is stable. It's a captive medium and low as well. The initial sources. So they would have like also nuclear comes in later on. So in a nutshell, the planning has started, maybe done meticulous modeling. It's not like so for the time apply for connectivity, and it's not like a small it's a big one, 1 gigawatt is really and it has to be complex apart from transaction apart. So just like the rates, national plan for transmission, therefore it is I believe there would be a national plan for citing possible sites where the data centers can open. That focus very clearly comes in later on. So otherwise, interaction here requires maybe suboptimal optimization. Therefore, the burden of tariff. It's not like for the time apply for connectivity. It's not like a small
From a national system operator perspective, how does the rise of AI-driven data centers change transmission planning in real-time?
Possible sites where the data centers can open.
First of all, I would like to thank the National Laboratory of the Rockies for inviting me and having me here today. Of course, this is the paradigm shift that we are going to see over the next few years. Data centers we consider as very dense and intense loads that are coming, unlike bulk loads that we used to have at the distribution level. Now these would be at the transmission level because sub-transmission level. I would like to thank the National Laboratory of the Rockies for inviting me and having me here today. Of course, this is the paradigm shift that we are going to see over the next few years. It is data centers we consider as very fast, sharp, and intense loads that are coming. Unlike variable loads that we used to have in the distribution, there are silent also transmission systems. Anything happens on the grid side, the data centers prefer to quietly isolate themselves. They are database disabled. I would like to thank the National Laboratory of the Rockies for inviting me. Couple of megawatts in the system quietly creates a system of standardization for the day. And the plan for it is handle this land manner rather than having it loads that are coming. So like variable, from this perspective, there are silent also transmission systems. Anything happens on the side, the system has to be there. Quietly isolate. As long as the connectivity is very good, Sheikh has already mentioned, reactive parts, lines, all right. Like check of this kind of things must be put in place. That is one side. The other side is the resource adequacy side. Such a large chunk of land for land, they must be land manner rather than having some of the energy reserves and balancing. So here comes forecasting. I understand in the AI, especially during the crop years, I understand highly unpredictable for forecasting the challenge and in place. That is one side. The other side is the resource adequacy side. One side. Such a large chunk of everything cannot be passed on to the grid. Grid cannot absorb all these risks. The other side, I think, is another important aspect is that many jurisdictions across the world require these data centers. Here comes mandatory some sort of generation. We have AI variations and crop nature adequacy. So I think India also our systems and classic codes and standards get involved in place. That is one side. The other side is the resource adequacy system. Such large resource energy storage it cannot absorb all these risks. The other side,
I'm just going to add that our laboratory partnered with Grid India 10 years ago, and it's amazing how many comments now today are similar to back then, right? It's like, how do you plan for all these needs? Something large, that's variable, that's coming out on the grid, that has impact on the grid. It's a lot of the same. I'm just going to add that our laboratory partnered with Grid India 10 years ago, and it's amazing. But one thing that gets me really excited is that now today are so much back then, right? It's like, how do you plan for all these needs? Something large, variable, that's coming out on the grid, that has impact on the grid. It's a lot of the same. Okay, so now as AI workloads explode, towers and one thing that gets me excited is that and why does that matter for data centers? Plan for
Silicon providers are the problem child. They are the ones that take power issue. So I think from an Intel perspective, we're trying to address it. First, of course, is the silicon level itself. So if you look at the process,
why does that matter for data centers?
first one is called pre-compliant. Silicon providers are the problem child. They are the ones that take power issue. So I think from an Intel perspective, we're trying to address it. First, of course, is the silicon design. So if you look at the process, the power interdependent. So with Power BI, we're able to get the power on the backend rather than provider. It is increasing the efficiency of the cell compared to 14%. So that's kind of number two. And the third piece that we talked about is something packaging. We have something called Power interdependent. So with Power BI, we're getting power to get the power on the single platform. Another thing is the efficiency of the cell compared to 18%. So that's the number two. And the third piece that we talked about is something packaging. So this changing of Power BI is about 80 days. The company has a system that what it does, we have always been very big. So Power BI will get the power on the single platform. Another one does not require the customer efficiency of the cell compared to 18%. So that's the third part as appropriate solution for the workload, including custom side. So we work with partners, the company customers, for example, the automotive workloads there. Another one does not require any customer workload process. What we want to do. Right? The third thing is, of course, the workload itself. AI as a proper work. I'll give an example, okay? Across about 15% or 15-second between end-to-end. Start from where you have the CPU and where you have the end output. But if you take a single task, so which is very comparable to run it on a CPU versus GPU mix, heterogeneous, or just or just a GPU mix. But if you want to just compare a single component saying, hey, what is my training workload on this? Right? Obviously, the heterogeneity doesn't work. So the way we are looking at is these three things, right? A, transistor level, make sure it counts. B, the third version of the system level, talking about properly designed I'll give an example, okay?
Okay, Mr. Krishnan, as AWS scales AI data centers globally, how do you decide where and how to deploy AI data centers so that it aligns with local
which is very comparable to run it on a CPU versus GPU mix, heterogeneous, or just or just a GPU mix.
But if what hasn't worked?
First of all, thanks to NLR for this opportunity. Good discussion.
If you want to just compare a single component saying, hey, what is my training workload on this?
It's not scaled yet.
Obviously, the heterogeneity
a lot of these problems are in the future.
The way we are looking at this is three things, right? A, transistor level, make sure it counts.
Months from now, and we still have an opportunity to correct it. Coming to what we as hyperscalers look for,
I'll give an example.
3-4 things. One is speed and certainty of power. So we have our load projections and let's say we need power.
Okay, Mr. Krishnan, as AWS scales AI data centers globally, globally.
end to end.
How do you
And
decide
then some
where and
visibility
how
on
to
the
deploy
output.
AI data
So let's say the
centers
data
so
center
that it
is
aligns with
150
local
Which is very comparable to run it on a CPU versus
We
CPU
obviously
mix
are not going to
heterogeneous
consume
or
that
just
power on a daily basis.
or just a
What has
GPU mix.
worked?
But if
What hasn't
meet
worked?
that demand, but we should have visibility of
First of all, thanks
is
to
there a network augmentation
NLR for
that
this
needs to be
opportunity.
done. Whether that will
Good
get
discussion.
done.
if you want to just compare a single component saying, hey, what is my training workload on this?
It's not scaled
Right?
yet.
Obviously, the
So a
heterogeneity
lot of
doesn't
the
work.
problems are in the
So our
future.
the way we are looking
We are
at
not
this is
facing it
three things,
today.
right? A,
100%
transistor level, make sure it counts.
from now.
This third that which is regulatory correct.
I'll give an example.
Three, four things. Then there are open access policies. One is speed and flexibility. Then there are certain permits and transmission planning. We see whether they have overload projection or happen that one is saying something else.
Okay, Mr. Krishna, as
And,
AWS scales
the last
AI
but not the least
data
is,
centers globally,
end to end.
how do you decide where and how to deploy AI data
So let's say the
centers
data
so that it
center
aligns with
are-
Which is very
local
comparable to run it on a CPU versus
We
CPU
obviously
mix
are not going to
heterogeneous
consume
or
that
just
power on a daily basis. We
or
need
just a
what has
GPU.
reasonable
worked?
But
certainty
if
What hasn't
meet
worked?
that demand, but we should have
This is not to
visibility
say
of
that the
First of
power
all, thanks to
plant
have to flat
NLR
allocation
for this
that needs to be
opportunity.
done. But we see that
Whether that will
good
get done
discussion.
or
if you want to just compare a single component saying, hey, what is my training workload on this?
It's not scaled
Right?
yet.
Obviously, the
So a
heterogeneity
lot of the
doesn't work.
problems are in the
So our
future.
the way we are
Okay,
looking at
finally,
this is
Mr.
three
Nanda.
things, right? A,
At TCS,
transistor level, make sure it
platforms like
counts.
Hypervault, you operate where AI strategy meets real-world execution. From a systems integration perspective, where do you see the biggest gap between AI
I'll give an example.
data center ambition and day-to-day operations? And how are integrated platforms helping you close that gap?
We see whether they have overload projection or happen that one is
Very happy to be here and
Mr.
with this.
As AWS
I think
scales
a lot has been said here
data
in
centers
terms of
globally,
end to end.
how do you
infrastructure
decide where
planning.
and how to deploy AI data centers so that it aligns
AI
Which is very comparable to run it on a CPU versus CPU mix heterogeneous
as
or
was
just
mentioned, is very
or just a
What has
GPU.
worked?
AI is
What hasn't
meet
worked?
that demand, but we should have
This is not to
visibility
say
of
that the
First of
power
all,
plant
thanks to
have to flat
NLR
allocation
for
that
this
needs to be
opportunity.
done. But we see
Whether that will
Good
get done
discussion.
or
If you want to just compare a single component saying, hey, what is my training workload on this?
it's not scaled
Right?
yet.
Obviously, the heterogeneity
a lot of
doesn't
the
work.
problems are in the
So our the way we are
Okay,
looking at
finally,
this is
Mr.
three
Nanda.
things, right? A,
At TCS,
transistor level, make sure it
platforms like
counts.
Hypervault, you operate where AI strategy meets real-world execution. From a systems integration perspective, where do you see the biggest gap between AI data center ambition and day-to-day operations? And how are integrated platforms helping close that gap?
more for inference load will probably be faster than what the US can do at the same time because the US is just
AWS
I think a lot has been said here in terms of
globally, how do you
infrastructure
decide where
planning
and how
as
to
well as
deploy
design.
AI data centers so that it aligns with
Which is very comparable to run it on a CPU versus CPU mix heterogeneous
as
or
was
just
mentioned, is very
or just a
What has
GPU.
worked?
AI
What hasn't
meet that
worked?
demand, but we should have
This is not to
visibility
say
of
that
First of all, thanks to
is now coming
flat allocation that needs to be done. But we see
whether that will
Good
get done
discussion. If you want to just compare a single component saying, hey, what is my training workload on this?
it's not scaled
Right?
yet.
Obviously, the
hyperscalers, like for example,
our the
Amazon.
way we are
Okay,
looking at
finally,
this is
Mr.
three
Nanda.
things, right? A,
At TCS,
transistor level, make sure it
platforms like
counts.
Hypervault, you operate where AI strategy meets real-world execution. From a systems integration perspective, where do you see the biggest gap between AI data center ambition and day-to-day operations? And how are integrated platforms?
AI models are coming at a pace which is much faster than the US infrastructure in terms of setting up power plants.
AWS
A lot has been said here in terms of
globally, how do you decide where and how to deploy AI data centers so that it aligns
Which is very comparable to run it on a CPU versus CPU mix heterogeneous or just a
What hasn't worked?
But we should have visibility of
First of all, thanks to flat allocation that needs to be done. Whether that will get done
if you want to just compare a single component saying, hey, what is my training workload on this?
it's not scaled
Right?
yet.
Obviously, the
hyperscalers, like for example,
our the
Amazon.
way we are looking at this is three things, right? A,
At TCS,
transistor level, make sure it
platforms like
counts.
Hypervault,
Be a factor not just of power infrastructure but also how to network these sites because ultimately all the data that gets stored in these sites
I'll give an example.
have to work with consumed outside the site. And it's that AI models are coming at a pace in terms of energy systems and large data centers as well as structures, the other terms of power plants.
What else needs to change? So I'm going to talk to these panelists about
what they would like to see change in terms of coordination, planning, policy, or something else that can help them keep pace with what needs to be. Okay, so we're going to go back in the same order. All right, Mr. Mandel, from an urban distribution utility perspective, what needs to change with distribution systems to keep pace with rapidly growing AI data sets?
Some of the good points I think in line of hyperscalers last year because the cost per work and also the models now satisfaction perspective. So resource planning becomes very important. Resource adequacy planning was a drop about 4 years ago. Which was very important.
So we have heard across the suite of panelists about many of the changes that are happening. But now what else needs to change? So I'm going to talk to the panelists about what they would like to see change in terms of coordination, planning, policy, or something else that can help them keep pace with what needs to be.
That will give you idea about where to site flexible resources. Like in case of hyperscalers, it would be more of chemistry change, but that's vanadium reduction. And they recently concluded India necessities. There were the vanadium redox 20 feet containers on display which can be, stacked up as a Lego brick work and also just like a Lego now. Very compact. It's like lithium so and which are long duration stories. So the chemistry is completely different. Long duration maybe 20 hours, 24 hours, more than that. It's kind of base challenges. So the planning particularly starts with the so just like we have connectivity regulation, that is the I would think this should be classified as a mass growth. My colleague was talking about in the connectivity regulation they should be given a special category that then for the planning wise tab only. Otherwise this may lead to chaos. Like in the case of hyperscalers, more might not be profitable or loaded on the end customers that might not be there with everything. So instead of doing all containers on problem play which can be the grid code, be the regulation that they want to the grid code and also just like the special status very compact. This kind of load hyperscalers and the GNA regulations to be there and which are then the systems are already there. So the chemistry is taken care of from the planning level 20 hours. Technologies are there which can kind of basically jump off, especially co-located generations balancing reserves and systems in our side. So this could be more.
What about you? What would you like? What changes would you really help out?
Planning, we start the planning phase itself. All information flow as well as coordination might not be profitable right from the start. Loaded on the end and what time we need to force and of efficiency as well as problem transmission and the system of and the most important part of the planning exercise is that models for studies and the systems are already there. Dynamic studies are taken care of the planning level. Technologies are mandated and they must be provided by the data centers so that and empower the data centers also on the electrical side also to develop expertise.
What about you?
RE integration phase. In the RE integration part, we saw that the developers were simply kind of trying to do plug and play. They were not bothered about the technical requirements. Planning will start were not equipped also to be able to carry out studies, information flow, all those kinds of things and take the replication largely profitable. So we would like to prefer that this kind of gap is not there for such it's not affordable. So that was one. On the planning side, on the operation side, very close coordination with the partners. Most important part of the balancing, providing models for studies and going forward already there. Provide node shifting, peak shaving, reactive power support also as ancillary services that can also they can participate in power. So all these services will become important on the electrical side also. So this kind of transportation must be developed, and they must come in as responsible citizens towards it. It also study.
Okay, Mr. Pukal, what design or system choices across the stack, from silicon to full systems, most effectively translate performance per watt gains into real efficiency at data center scale?
Overlooked the need for cost and sustainability versus design. Quality versus cost is never true. To be able to be sustainable, design that's sustainable over time is very possible. The beauty is to happen. More, there are data centers out there with 1.06, 1.1. But if you look at the AI setup, what was the consequence of AI? Not able to achieve that.
What design or system choices across the stack, from silicon to full systems, most effectively translate performance per watt gains into real efficiency at data center?
What does it require? It requires, as I said, heterogeneity of platforms, overlooked power and cost and sustainability issues that competition other than second is the IOS for quality versus I think for totally the next level, design should be sustainable over time, that is optics also huge about last but not the least, I think more, there are as the status out there, or as I said, 1.06 to look always very right, what's the open ecosystems for organization and others need one sustainable technology as we and AI. So if I were to ask you a question for scaling step one, now what does it say about be firm about setting, as I said, UV standards, so that reduces our sustainable work, empowering lives, really need to look at need conversation about what that's one or third, I think there needs to be, and that India has done well, given the state government and open source of IT, right? More, I would as
Okay, Mr. Krishnan, from AWS's experience scaling AI data centers worldwide, where do coordination challenges with utilities or regulators most often slow deployment, and what has proven most effective in overcoming those
what does it say? Fundamentally, the form of cloud services versus I think there's a lot of confusion about that. We as hyperscalers should also do a better job explaining. He said that AI data centers don't behavior as a that India has done well. Needs to be dealt with. So that one thing I think it's a challenge in the sense that both of us have to come together and explain that how it needs to be. Like what our expectations are. Our expectations also are slightly different for an AI.
What has proven most effective in overcoming those?
That's one. Second is just the planning cycle. As you can see, our planning horizons I think the transmission planning cycle, state level at least, is regulatory setting cloud services also. The planning cycle, there's a lot of confusion, and somewhere the planning cycle, as we as hyperscalers, should be more explaining. Third is more policy. India has really understand which also touch abundance of needs to be dealt. There are multiple models. So that one thing I think virtual power purchase can buy right from market. Both of us are from this physical explain that but how it needs to be. So let's talk about our expectations. Our expectations state-wise it is in some states there is a monthly validation. In some states time of use. Second is in some planning states the banking is little free.
policy across the help us to take better decisions and planning cycle. Last but not least, there are policies incentives. Third is more policy, certain waivers, but on ground the implementation of these policies is but then that's what we have seen. There are multiple. There could be an electricity duty waiver, and one thing is but on ground there are administrative processes in place, but it's how it needs to be. Let's talk about expectations. State-wise,
Okay, Mr. Nanda, as AI data centers move toward higher power densities and cooling, where do traditional data center models break down? What needs to be rethought from the ground up?
Data centers, last but not least, the design philosophy is very different. We're going to get together on day one. Semiconductor manufacturing, honestly, that probably did not happen in the first 20 years. It was going to look like a building where you just go and put racks. These are going to be complex energy systems, so that's one big change that will happen. That will just given the kind of how it works. But I'll also add to the comments in terms of what else can India do something there is at an advantageous position.
Okay, Mr. Nanda, as AI data centers move toward higher power densities,
not that in many
where do
countries,
traditional data center models break down? What needs to be rethought from the ground up?
those countries which use us in much. The Indian state is currently not completely investment business. The design philosophy is that's super attractive. We're going to get together on that is not the case internationally. And I hope that remains in fact, till we become a force to reckon properly did not out. So on the question of the coordination of policy, I think if all of us speak in unison with the states who are one big vying for investment, we'll have to make sure that those investments are translated. But also infrastructure projects in big time in terms of, I think what you have said as such very, very well is we're just learning from the issues that what data center we are now in the United States of America facing that one example because that's also where maximum is out of I think India has a huge manufacturing footprint right now, and a lot of that has come in especially on the power side. You say wind turbines together is not the case at all. Whether it's wind turbines or gas turbines or steam turbines, so till they become the US, of course, that's maxed out and there is no way. So on the question of the coordination of companies like say, all of us Siemens and so on are sold out completely in the States. We have that capacity, same with India investment. So I think this is the moment for us, our investment has been said by my practice. For us to quantify by state, by nation, what the issues that demand, and then kickstart the manufacturing process so that we have a gear in place that has this exponential growth takes off. Finally, also sources of power. So we talked about renewables. I'm also a firm believer that we will also need back of the meter power in the sense that these devices will have a state at some point in time. And to that extent, India should lead the US approach towards gas-based power generation. We as a country have more than 45 million tons of import capacity sold out, and that's ideally located across the periphery of countries. We have a very good pipeline network, and that's again for us as scalers, as the zones where they want to build out large data centers. For us to augur extremely well by state to kickstart gas-based power kickstart for these plants because when it comes to affordability, data center operators that may not be the issue as compared to conventional power because it was mentioned earlier. I'm also from the Abhishek mentioned that ultimately my user should buy consumer, which is the consumer that they serve currently as a distributor should not get impacted on the cost of electricity. That's another policy dimension that we should gas-based power generation.
We can have a whole other session on rate design. For now, let's just, we'll have a lightning round. And so for each panel, of this panel. So, what to address any of your biggest disconnects today between where you are, where you're going, what others are doing? What is one collaboration that could close the gap fastest? And I will take any one. Lightning round.
Adoption of user progenitor system
We can have a whole other session on rate design.
This is the design of the hyperscalers, technology collaboration,
And so for each panelist,
just like you have equalizers,
is collaboration.
flex.
So, of this panel. So, what to address any of your biggest disconnects today between where you are, where you're going,
Which I think they already
what is one collaboration that could close the gap fastest?
Good and bad thing at
And I will take any one.
AI data center power density is high. Footprint you're talking about gigawatt capacity. Why I'm saying it's good and bad? It's bad because you would want the data centers to be small, so that the strain on the network is not. Why I'm saying it's good is, you know the pocket that
We can have a whole other session on
like Dipesh rightly mentioned, he
This is
spoke about
the design of the hyperscalers,
we exactly know the pocket
And so
where
for each panelist,
just like you have
we should give special attention to those pockets when it comes to network augmentation, much ahead network augmentation. Like Sachin as you rightly said, there could be a problem of fault current which I think voltage. So the good thing is that you can arrest it at that point and retain proper checks and balances. Power density will calculate itself and it will not be possible. So planning, why I'm saying it's better at planning, more localized planning. I don't see problem on generation so that upstream transmission. Why I'm saying it's good when it comes to localized pockets that is where Dipesh rightly mentioned is spoke about the design of the hyperscaler.
wonderful. And then on our last few minutes, do any of you have a question for one of the others on the panel?
Special attention to those pockets network augmentation, much ahead network augmentation.
I'd like to take this opportunity to ask what's a view on battery energy storage and the role that it will play to stabilize grid power for large data center campuses. Any thoughts on that? Because that's a topic that we are looking at. And I know that India has embarked on a journey of buying massive capacity of battery energy storage. How do you see that playing out?
Specialized data centers. In fact, that is where you can actually absorb the lines and maybe provide backup, provide reliability service, provide voltage support. All those kind of reliability services can also come out of the battery energy storage systems. In fact, offer some sort of shifting of demand as well. So all
What's a
this
view on battery energy storage and the role that it will play
form of local support.
to stabilize grid power?
Dipesh, just to add, this is another commercial opportunity. What thoughts of that? You run data centers, that's a topic that is a big thing. But then when you add these resources from lithium and talk about any other chemistry, which I don't see probably the vanadium, there could be many other sodium ion batteries, long duration ones, because this is a very stable base kind of load.
In fact, that
So if you have these,
you can actually
and then the regulations which are in place, ancillary services regulations, maybe amended, PS, ancillary service on market is already there, as well as ancillary service and primary, some sort of market-based opportunity, short-term future. So that could be a way where you are making your life easier. Also, there is a money-spinning opportunity where in your definition valuation stream, one of the lines of commercial opportunity, how I am placing my data centers without losing their reliability opportunity. And then when you add the next one thing, Jacqueline, I want to add here, talk about any other as we are becoming more and more data dependent, they definitely are going to be very, very crucial and critical infrastructure. As like India or anywhere else, we are classifying the power infrastructure as very critical, maybe a mandate, and they are very soft targets. Now, the islanding schemes of power in India, for example, for cities like Mumbai, Delhi, Hyderabad, where these data centers are the future, of the future. So that would be a way where you are making your life easier. Also, if the islanding schemes are not properly operational, in Mumbai there was a case, I think, in October of 2020, there was a because of some something happened. There was cascade. The hydropower in the western Ghats were not able to supply power to the so those things will be very bad. So the data centers, why the data centers, if they fail, very, very crucial medical life support, your hands, India, airports, power is there all going to die. So therefore the islanding schemes just now, the islanding schemes where power is more India, because it's no longer a power thing, it's going to impact your lives. Data centers are now heart of life, heart of future.
Well, thank you. This has been a fascinating discussion, and it is clear that all these choices that we're making today are going to be shaping our economy for decades to come. And I want to give a round of applause to our panel.
Something happened. There was hydropower in the western Ghats were not able to
Okay, but others, do you want to come up? I'm going to invite now my colleague Others Nagarajan to give, and then stay for the next panel. We're going to be going more into data centers.
Airports, power is there all going to die. Therefore, the island
Stay back and ask your questions, sir. It's a very important topic, but a little later once we end the session. Stay over.
No longer a power thing.
Is it?
Impact your lives. Data centers are now heart of life.
We'll figure it out, sir.
Well, thank you. This has been a fascinating discussion, and it is clear that all these choices that we're making today are going to be shaping our economy.
As a data center and the growth is rightly mentioned by Jacqueline. What India went through 10, 15 years ago, huge change in demand. Here in this case,
Others, do you want to come up? I'm going to invite now my colleague Others Nagarajan to give, and then stay for the next panel. We're going to be going more into
hundreds of megawatts. And as this committee so rightly pointed out, stay back and ask your questions. It's a very important topic, but really successfully implemented. There is a knowledge and a handshake across all the stakeholders, the chip manufacturers, the model developers, the solutions, DISCOMs, and the national grid operators all tied together. There is a harmony of knowledge. That's the center and the sector always right. And I believe the leaders here have already communicated that what India then and with that I want to take a huge change and need to provide the momentum to all these cases.
Others, do you want to come up? I'm going to invite now my colleague
Let me invite Jacqueline, VP of Fight CEO of the Art of the Momentum. And as this committee so rightly pointed out, very important topic, but really successful. Let's have Mr. Samir all the things and thank you, sir. Chip manufacturers, model developers, solutions, DISCOMs. Let's have all right together. There is a harmony of knowledge. That's the sector and the sector always right. Thank you. I believe the leaders here and Mr. Nanda. What India has done, and with that I want to take a huge change and need to provide momentum. Thanks a lot. Please stay back. We have an equally interesting yet more technical session following right after this same place. We will be replaced with more eminent guests as well. So please stay back and listen to the rest. Thank you. The momentum. And as this committee so rightly pointed out, stay back and ask your questions. Very important topic, but really successful. Let's have Mr. Samir all the things and thank you, sir. Chip manufacturers, model developers, solutions, DISCOMs. Let's have all right together. There is a harmony of knowledge.
back and listen to the momento. And as the company provides Please stay back. We have an equally interesting yet more technical session following right after this same place. We will be replacing with prominent guest as CEO. Please stay back and the momento.